Quadratic function in standard form. Today we are going to discuss another kind or form of quadratic function, and that is in standard form. Remember, we've discussed already about the vertex form of quadratic function, and this time we are going to discuss another form, which is the standard form. Okay, the standard form of quadratic function is y equals ax squared plus bx plus c. As you can see, in this form of quadratic function, there is no h in k, which is present in your vertex form. But instead, you have here the value for a, b, and c. So in standard form, you have a, b, and c. In vertex form, you have h and k. Now, in vertex form, we know that we can immediately identify the vertex by simply getting the value of your h and k in the function. But since in standard form there is no h and k here, therefore we cannot immediately identify the vertex. Now, how are we going to find the vertex of a quadratic function in standard form? That is our topic for today. The first thing that we need to know when we are solving or when we are finding for the vertex and other properties of quadratic function in standard form, first we have to identify first the value of your a, b, and c. Now, a here is a coefficient of x squared. So it is always beside your x squared. So it is a numerical coefficient. That means it is a number with x squared. Bx or b here is the coefficient of x. Notice that the coefficient of x here is 1. Okay, so the coefficient of x raised to 1 here is your b. While here, the exponent of your x here is 2. Okay, which is the leading term. Okay, so the leading term here is ax squared and the coefficient is a. Now, c here is the constant term or a number term. This is a term without a variable. So let's say you have y is equal to 2x squared plus 3x minus 5. Let us identify your a, b, and c. Remember, a is the coefficient of x squared. So your a here is 2 because your x squared is here. Right? So your a is 2. B is the coefficient of x, and that is 3x, so therefore your b is 3. And c is the constant term. Again, constant term is a term without a variable, so that is negative 5. You have to include the sign of the term, so negative 5. Another one, let's say you have y is equal to negative 3x squared minus or plus 5x minus 4. Okay, so what is your a? Again, your a is the coefficient of x squared, so that is negative 3. Your b is the coefficient of x, so that is 5. And your c is the constant term, which is negative 4. Another one, y is equal to x minus 4x squared plus 7. What is the value of your a? Remember, a is the coefficient of your x squared. Now your x squared is right here, therefore the coefficient is negative 4. Sometimes the function is not written in descending order. When you say descending order, that means from the leading term or with the term with the highest exponent up to the constant term. So in this case, the function is not written in descending order. So be mindful of the exponent of the variable. So it is not all, your a is not always in the beginning of the function. So b here is the coefficient of your x, the variable with an exponent that is 1. So this is your x, the exponent here is 1. And what about the coefficient? If you don't see a number here, that means that's 1. It's not 0, it's 1. And c is 7. Okay, let's have the last one. Y is equal to 4x squared plus 2x. What is your a? It is 4, and your b is 2. And what about your c? So here you don't have a constant term, so your c is 0. Okay, so now that you know how to identify your a, b, and c, let us now solve for the vertex of the function or quadratic function in standard form. Let's say you have y equals x squared minus 4x plus 1. When you are looking for the vertex, always remember to get first the value of your a, b, and c. So in this function, y equals x squared minus 4x plus 1, what is the value of your a? Your a is 1. Your b is negative 4. And your c is 1. Okay, so we already have the value for a, b, and c. Now, how are we going to look for the vertex of the standard form if there's no h and k? Unlike in vertex form, you can simply get the value of your h and k, and then that will be the vertex. But since there's no h and k, how do we solve for the vertex? Remember that a vertex is also a point. So a vertex is a point or a turning point of the quadratic function. So if it's a point, that means that there is an x coordinate and a y coordinate, right? So since we are looking for a point, we are going to solve for the x coordinate and the y coordinate of the function that is also the turning point of the graph. So how do we solve for that? If we are going to solve for x, we are going to use the formula negative b over 2a. So to look for the x coordinate of the vertex, you will use this formula, negative b over 2a. Okay? So how do we solve for that? So we need a value for b and we need a value for a. Now we already identified the value of your a, b, and c, so we are now ready to solve for this formula or for your x. So you just simply plug in the value of the given a, and b. Actually, you don't need c, but for discussion purposes, we are going to identify your c. So your a is 1 and your b is negative 4. You just simply plug it in here. So negative b here means negative of b. So if your b is negative 4, that will be negative of negative 4. And you can just simply say opposite of b. So if your b is negative, make it positive. And if your b is positive, make it negative, because we're getting the opposite of the value of b. So that will be negative of negative 4 all over 2 times your a is 1. See, when you get the opposite or the negative of negative 4, it becomes positive, right? So 4. Okay, so you can just simply write 4 over 2 times 1 is 2. And then your x is 4 divided by 2 is 2. So you already have your x coordinate. So therefore this is 2. So we already have the x coordinate here. We are now going to solve for the y coordinates. So how are we going to solve for the y coordinate? To solve for the y coordinate, okay, solve for y, we are going to use the function itself to solve for y. Since we already solved for your x, we already have the value for x, all we have to do is to plug in or to substitute the value of x that we just solved to the given function to solve for y. So y is equal to x squared minus 4x plus 1, right? That is our function. So we are going to solve for y. So we just simply plug in this function to, or this value of x to the given function. So I will just change all my x with 2. Instead of writing x, I will write 2. So x squared, this will become 2 squared minus 4 times 2 plus 1. Remember to substitute 2 to all your x. Then we are going to perform the expression with exponent. So 2 raised to 2 is 4. Negative 4 times 2 is negative 8 plus 1. Now let us perform addition and subtraction from left to right. So 4 minus 8 is negative 4 plus 1. Negative 4 plus 1 is negative 3. So your y is negative 3. So this is negative 3, right? Now let us also discuss the other properties aside from the vertex. Let us identify the axis of symmetry, AS for axis of symmetry. So axis of symmetry is actually the value of your x. So that will be x is equal to 2. This is also your axis of symmetry. So negative b over 2a is actually your axis of symmetry. Right? So if you're asked what is the axis of symmetry, just use negative b over 2a. Then next, let us identify the opening of the graph. So how do we identify the opening? The opening is based on the value of your a. If your a is positive, it will open upward, and if it's negative, it is downward. It's the same with the vertex form. We've already discussed this before. So since your a here is positive, it will open up, right? And now let's try to sketch the graph. Okay, so this will be the graph. Let's try that. So 1, 2, 1, 2, 3, right? This will be the vertex and will open upward. Okay, so since it will continue to go up infinitely, therefore there is no maximum, and if there's no maximum, therefore there is a minimum. Okay, this is the minimum value. The minimum value is negative 3. So this is minimum. That is negative 3. Notice that the minimum or maximum is actually the value of your y. So this is also the minimum or maximum. So minimum, maximum depends on the opening of the graph. And the value is actually the value of your y. Okay? And what about the range? Range, it starts from negative 3 up, right? It will, all values of y starts from negative 3 up. See, your graph will continue to go up. It means that the graph starts from negative 3 upward. Those are all values of y occupied or part of the graph. So therefore, and all numbers from negative 3 up are all greater than negative 3. So that is y is greater than equal to negative 3. Okay, let's have the next one. Y is equal to negative 3x squared plus 12x minus 8. Let us identify first your a, b, and c. Okay, what is your a? Your a is negative 3. Your b is 12. And your c is negative 8. Don't forget to include the sign. Okay, now let us now solve for the vertex. Again, to solve for the vertex, we need the x and y coordinates. So we need to solve for x and we need to solve for y. To solve for x, we are going to use the formula. So we are going to use the formula x is equal to negative b over 2a, right? And x also, the value of your x here is actually the axis of symmetry. So let's start. So this is negative 12, negative b. That means this is negative 12 because the opposite of positive 12 is negative 12 over 2 times your a is negative 3, right? So negative 12 over 2 times negative 3 is negative 6. Let us simplify. Negative divided by negative is positive. 12 divided by 6 is 2. So your x is 2. Right? Now let us solve for y. To solve for y coordinate, we are going to use the function. We will just simply plug in the value of your x to the given function so we can solve for y. Negative 3x squared plus 12x minus 8, right? And we are going to change all our x with positive 2. So this becomes negative 3 times 2 squared plus 12 times 2 minus 8. Okay? Now if you have a calculator, you can just simply put this in the calculator, then press enter, you'll get the value of y. Okay, so negative 3, 2 squared is 4, plus 12 times 2 is 24, minus 8. Negative 3 times 4 is negative 12, plus 24, minus 8. It's not 18, it's 8. Minus 8. Okay, perform addition and subtraction from left to right. So negative 12 plus 24 is 12 minus 8. 12 minus 8 is 4. So your y is 4. Now remember, x here is also the axis of symmetry. So the axis of symmetry is x is equal to 2. And this is your minimum or maximum. Now let us identify first the opening so we can identify whether it's maximum or minimum. So it will open. This is negative. It means that it will open downward. So if it will open downward, therefore there is no minimum because it will continue to go down. You have a maximum value. What is the maximum value? This is your maximum value, which is 4. Okay, and what about the range? It will continue to go down, therefore the numbers are less than 4. So y is less than or equal to 4. Okay, now during your tests, your quizzes, or your warm-up, you can use Desmos graphing calculator. So you can simply graph this using Desmos graphing calculator and identify the following properties. So whether it's standard form or vertex form, you can use Desmos graphing calculator if you already know how to identify the following properties using the graph. But if you don't have a Desmos graphing calculator, you will use this process to find the following properties.